Hello, my name is John Lee, and this is my project on the predictive model for student dropout success. My project revolves around predicting student dropout and success rates based on a student's academic path, demographic, and socioeconomic status. The goal of this project is to determine which academic path has the highest or lowest dropout success rate, as well as whether there's significant correlation between the student's demographic and success rate. So my data is called the Predict Student Dropout in Academic Success. It's from a study done in Portugal from the UCI Machine Learning Repository, and this is a preview of what the raw data would look like. The data information, this is the data information and has a mix of 3 different types of data, such as the discrete, continuous, and categorical. Discrete is the majority of the data within this data set. The next is the dictionary of the data set, which I created to link the numbers in the raw data to its name, so it would be easier to just read instead of just a bunch of numbers. And I did that for every data point, and this is a snippet of what the names of what it would look like with the names rather than just the numbers like 1, 2, 3, 4, 5. So for the data cleaning, I filled in the missing values in the data set. Then next, I renamed the columns for better readability. So I pretty much shortened the length of the longer column names, such as the daytime/evening attendance, to just attendance, so it's easier to read. Then I did the encoding categorical variables, which is pretty much identifying categorical problems in the data set, and it used the one-hot encoding to convert them to a binary column for each category, such as if there was a gender category and then it would split into the male or female. Next, I handled any duplicate data by removing any of the duplicate rows in my data set. And finally, I dropped all the irrelevant features I feel were not necessary to achieve the goal of my project, such as like marital status, previous qualifications, depth, all of the irrelevant columns in my project. And then I printed the data, and this is what it looks like after all the cleaning. It has significantly less columns than before, and it looks more neat. Next, for my analysis, I looked at academic path versus a student's success and success rate, where we could see that some classes have a higher success rate than others, and we could see the average grade distribution for each of the courses down below. Next, I looked at the percentages of graduates, dropouts, and those currently enrolled, which the graduate success rate is around 50%, while the dropout is 32, and the enrolled is a little under 18. Then I looked at the different success rates between the different genders, and as we can see, the females have a significantly higher success rate than the males. And then we can see the gender distribution between all the classes. And then these are the grade distributions between the graduates, dropouts, and enrolled. And as we can see, there's not much of a difference between the 3, but the graduate admissions grade does have a higher mean and median than the other 2 currently do. Next is the correlation matrix between the different features of my project, such as like the admission grade to the previous grade, where it does have a high positive correlation, while the GDP and the employment rate has the lowest negative correlation. These were just different models that I could have used as I was planning out my model approach during part 2, but I ended up, for my learning machine approach, I ended up using the logistic regression model. And this model leverages features such as emissions grades, employment rates, unemployment rates, and more to predict a student's outcome. I've also explored fe feature engineering, hyper hyperparam hyperparameter tuning, techniques to handle the class imbalances, all to fine tune the model's performance. And this model the model the model provides insight into factors driving student success and dropout. It highlights the significance of the features such as the emissions grades and the socioeconomic conditions. And while the model excels in predicting the graduates, I acknowledge the challenges in accurately predicting the enrolled students. And this will help guide the ongoing improvement of the project further down the line. And then as you can see, the app takes in input values such as the emissions grade and unemployment rates and accurately predicts and then generates predictions for student outcomes. So the model does achieve an accuracy of 48% on the test set. However, the macro average F1 score of 0.26 and the weighted average F1 score of 0.35 indicate that the model's performance was suboptimal compared to other type of models. Next is I use different visualizations on each, such as feature important plot, which shows which features were important to the prediction of the model, a calibration curve to assess the model's predicted probabilities against actual outcomes, and a learning curve, which can help identify if the model would benefit from more training data. I also included like alternate evaluation matrices, model iteration and cross-validation, and then a brief conclusion of the machine learning model. Then the overall conclusion is broken up into multiple parts, such as my learning takeaways and the model performance and improvement, and then the future directions of the project. And then finally, it concludes with the overall conclusion about the whole entire project. And that would be all. Thank you for your time and have a great day.